Hey folks, sorry for the delay. I just had a little bit of trouble with my streaming software, sort of an ongoing issue with it recognizing my text editor and um, browser properly. So, um, yeah, just getting that going. That's what was taking me a while. So let me get caught up here. Okay, cool. We're starting right off with a question, which is great. Okay. So we have a question regarding dictionaries. The person is asking, having a reoccurring problems with not being able to iterate past the first instance. It is challenge 3 for traversing dictionaries from intermediate Python. Excellent. Cool. Let's take a look at this. Cool. Yeah, go ahead and put in your combinations question as well. I'll get to that after this. Cool. Let me just set up here. Oops, this is something else. Open that. Okay, actually, let's just go to the link first. I'm just going to stash this old code. Dump it in that file real quick. Okay. Okay, we've got something still running. Where is it? Oh. Okay, cool. Good. Sanity check complete. Dictionaries. All right, we're looking for problem 3 here. And I will paste in the code. I'm just going to copy in the problem statement first, though. We'll just work out of the text editor. My preference, as I'm sure you know by now. Okay. And let me get your code in. Oh. Slack just wants to have a little meltdown, which is really nice of it, I guess. I'm just going to be snarky and sarcastic about it. Oh, come on, Slack. Come on. Let's copy that code. Okay. So I think I got all of that in. To the question asker, can you just confirm that that code is correct, what I have on screen there, just when you get a second? I'm trying to verify that myself. Okay. Oh, there we go. Yeah, okay. That shows it to me. Oh. Good, that looks the same. Okay, cool. So let's see what this question is all about. First, let's just run it, make sure I didn't get any weird characters from Slack. Probably did. Okay. Looks like we're okay. I'm just gonna get a preempt the test here. We'll start writing a test. I haven't even read the problem yet, but we'll start writing a test anyways. Right away I see an issue having to do with the indentation. You were saying you can't get past the first iteration. Ask yourself, what happens when your function encounters a return? If you think about that, that'll give you some ground on this. I'm going to let you think about that. Get back to me if that clicks for you. I'm going to read through the problem. We're going to go through and solve this problem anyways, just to do it, and I'll talk about how I would approach it and all that after. And I'll talk about the error that's happening here that I see right off the bat. That's probably the thing. Yeah, cool. So write a function called find values that takes two parameters. Okay. The first parameter called, we'll just say search dict is a dictionary. The second parameter val to find is a specific value to find in the dictionary. If the value is in the dictionary, it should return a list of the corresponding key or keys if the value occurs more than once. Okay. So we're going to see if this value is in the dictionary, and if it is, we're going to return a list of the keys. A list of the keys that hold that value. So if the value is not in the dictionary, it should return the phrase the value does not exist. Okay, cool. So right away we'll handle this edge case after we write our tests. So I'll write the tests. So let's do this. D equals a dictionary. We'll say A has a value of 5, and we'll just make a couple more of these. B has a value of 5. C has a value of 3. And let's do this. So we'll pass in the dictionary, and we'll see if 5 is a member of the dictionary. And let's do key D has a value of 7. Okay. So if we pass in D, which has these 4 keys, and we look for all the keys that have 5, we should get a list that has 5, or that has A, B. That should be the list that we expect it to return. So let's we'll also look for 3. That should give us C. Just a list of the single element. 7 should give us D. And 8 should give us, excuse me, 8, what am I doing? 8 should give us this special case here. That value does not exist. Yeah, that value does not exist. Good. Okay, so we have our response. So the person is saying, okay, the return key list is at the wrong indentation. Yeah, this is what I was noticing as well. So this looks like sort of the intended primary return, you know, the main return of the function, and since it's in the for loop, the for loop is going to encounter it no matter what, since it's not guarded underneath a a condition. Yeah, exactly. It should be parallel to the for in the first level, indentation level of the function like this. So it should be there instead of there. Okay. Gosh, what's wrong? Okay, there we go. Cool. So we have a few tests here. I kind of see what was happening here. If you look at this, it's checking if the value is equal to value defined. Then we have this return of the value does not exist. This is really an edge case. This is handling a scenario that is a potential, but it's not really the primary case, right? So these are the primary uses, sort of the or sort of the main body of the logic. That's how I see it, is returning a list of all the keys. And then we have this special case that says if the value is not in the dictionary, then we're going to return this special sort of other thing. This is an edge case. So by convention, the way you handle edge cases is just right up front. You just handle them right in the front. So we'll say if, and what we want to do, I want to take this return line here. We'll just move this up. Put that in there. Okay. Get rid of that else. Okay, and we want to say if val to find not in. Now we want to see if it's not a member of the values. So we'll do search dict dot values. Okay. And so this is saying if the val defined is not a member of the values of the dictionary. This is a list of the values of the dictionary, essentially. Then we'll return the value does not exist. So we can just do that right up front. And from here we can just assume that it's in there because we've already either returned if it's not or something else, you know. Cool. So let's see, we have an accumulator. Good. We'll say for key value in searchdict.items, if value from the dictionary equals to value is equal to value defined, then we're going to append the key to key list and return it. Cool. That looks like it's going to work to me. So we should get this pattern. Okay, so we get that value does not exist and that value does not exist. A, B, and A, B, C, and C, D, and D. Good. So that's what we expect. It looks like it's passing our tests. These are, just to be clear, this is what I mean by our tests. It's passing these tests that I just wrote. Hopefully that's clear what I'm talking about here and why we're getting duplicated output. The second thing that I'm passing to print is what I expect the function to return. That way I can just quickly visually inspect it and see if I got the same thing that I expected. We could actually, I think I'll just do this. I'll just make this clearer. Oops. I'll do that. And that. And then curlies. And let's put this on a new line. Let's say found colon backslash n backslash t and expected okay, cool. Oops. Maybe that'll make my output a little clearer. Oops. Cool. All right. So we have each of these tests. Now each of these tests print. Guess we can get rid of these. Okay, cool. So this is saying what it found and what it expected. That value does not exist. That value does not exist. Found AB, expected AB. Found C, expected C. Found D, expected D, etc. So that's why I write these in that way. Good. All right, sorry, let me catch up with the comments. Should have been in parallel. So is val defined? Yep. Oh, let's see. Let me copy that question in. Sorry. All right. If val define. Oh, okay. So the OP is asking if these two are equivalent. Val define not in search dict.values equivalent to not val defined in search dict.values. I think these two lines would be equivalent. Let's see though. Let me just paste this into learn and we'll rewrite it and try it both ways. That's always the way you figure it out. You know, just get Python to, you know, if it's not going to work, it'll tell you. So, not. Okay. So it does work with val defined not in. Now let's look if not val defined in will work as well. Yeah, it looks like those are equivalent. So, good. I like to do this with not in. It just reads, I mean, obviously it just kind of reads more like you'd say it in English, so it just feels more natural to me to just say not in, but I think not val defined in also works as well. Cool. Sure thing. Yep. All right. I'm going to move on to the next question. This is a good one. I enjoyed this one. Okay. So, combinations, question 2. Referring to challenges Q1 and Q2, the permutations lesson in Statistics Club. Oh, okay. For the second question regarding combinations, I'm having a hard time following. It sounds like you got combinations Q3. Do you want help with combinations? Wait, do you want help with combinations Q3 or Q2? I'm a little lost. Also, can you put a link to the questions? in Learn. I don't really want to go like search for them. So if you can just give me a link, that'll make it easy. You got Q2 and you need help with Q3. Okay, cool. I just close that. Okay. Oh, Google Chrome is so slow. Cool. Thank you. Thank you for the link. Let's actually just do this. Okay. Using the combinations formula to calculate probabilities. Well, you need to kind of build this from scratch. So I'm just going to build a combinations formula in Python, and we'll just have that be our tool. So I know we need factorial, so we'll do def factorial. I know I say to test everything, and I'm not testing factorial before I'm writing it, but I've written factorial, I don't know, probably a lot. So we'll do for num in range in. We'll start at 1, we'll go to n plus 1, and we'll prod times equals num. Okay, cool. So our combinations, is this the right? Yeah, so our combinations is going to be this will take in, oops, and this will return, excuse me, return, little hiccup there for you. All right, this will return factorial n over factorial n minus r times factorial r. Or excuse me. I want to call this k because that's what I like to do. Cool. All right. Got to put parentheses around that so that since we're following PEMDAS, right? PEM for multiplication comes before division. Actually, how about that? I think those are actually parallel. So in this case, this would occur first and then be multiplied by that, so that can throw things off. Or maybe I'm wrong, but just put parentheses around it anyways. That'll just make it, clear what's happening. All right, cool. Let's go check out this third challenge. Okay, if I recall, this is one of the ones that builds off each other. So I think I need to do Q1 and Q2 if I'm not mistaken. Refers to challenges Q1 and Q2 and oh no. Oh gosh. Okay. Refer to the above challenge. Oh my gosh. Okay. So I have to do Q1 and Q2 in permutations, and then Q2 in combinations before I can do Q3. Okay. Okay, so let's see. permutations. Let's get our permutations function just sorted out here. Let's find a permutations algorithm. Oh, well, there's actually one just written right there. So this is actually permutations right here. So I'm just going to do def permutations. We'll take in n and k and return factorial n minus k times factorial k. And this, I'm just going to do permutations in k. Cool. Okay. Where is it? There it is. Let me just write a little. We'll do perm q1, perm q2. Then we need to do comb q2 and comb q3. Cool. So we'll just go through each of these and go from there. So the local statistics club at a university is choosing leadership for their 18 members. There are 3 leadership positions to be filled: president, treasurer, and secretary. In how many ways can these 3 positions be filled? How many ways? Okay. I need to do this like this. Statistics Club of local university is choosing their leadership from 18 members. There are 3 leadership positions to be filled. Okay. President, treasurer, and secretary. In how many different ways can these 3 positions be filled? Okay, so let's just do print. Permutations, and we need our, I think we have 3 positions to be filled. Or am I wrong about this? 18. Alas, I don't remember how to solve this one. I don't think that's it. Let me see, because I know I've done this one before. Apologies for this. This is in, let's see. So I think I've done this one before. I just did it in basic prep. I'm so much more a programmer first before I am a statistician. Basic probability. Come on. $120. Okay, Cool. So we'll do 120. Oh my god, there's so much scrolling. 120. I guess I don't even need to do this. Okay, this one. Statistics Club is choosing their leadership from 18 to assume that there are not any members sharing the same first name, and we know Lucy has been previously chosen as president. Given this information, what is the probability that two arbitrarily chosen club members, John and Jane, will fill the two remaining positions? Okay. Yeah, I'm going to have to back out on this one. I have solved these in previous go-arounds. I tend to be really slow at stats, honestly. So in the interest of making the best out of this study hall, I'm going to just ask that you ping Tovio on this, and Tovio should get back to you pretty quickly. Sorry about the confusion on this. I'll look into this also afterwards and see if I can get you an answer after study hall. But I think just going through this on stream might not be the best use of time. So, cool. Yeah, these are tough ones. Yeah, sorry about that. Okay, cool. I think we could go through a few more of these dictionary ones, though. Okay, cool. All right. So yeah, let's just do the rest of these dictionaries because I don't know, I like them. I'll do something I'm good at. So, what is returned when the dot items method is called on the dictionary? That's going to be a tuple. It's a generator that returns a tuple of the key followed by the value. A list filled with list-like objects, kind of. This is not really. A tuple filled with list-like objects of length 2. A list-like object filled with lists of length 2. A list-like object filled with tuples. That seems like it fits the closest. Cool. Yeah, so the dot items method returns an iterable, which is like a list. What it's actually called is a generator. So dot items is a generator, which means if we do something like print d dot items, we don't get a list of the items, but we get the dict items object returned. And I can cast this easily as a list like this. Cool. And if we ask for the type of it, it's going to be class dict items is the name of that type. So it's actually its own, technically its own type that it returns. Cool. It actually might not be a generator technically, but I don't know. It's not a list. that's for sure. Okay, let's do this one. Write a function called reverse dict. Takes in one dictionary as a parameter. Return a new dictionary that is the reversed version of the... What? Dictionaries can't be reversed. Oh, I see. I was like, wait, dictionaries aren't ordered? What is this asking? This is return the dictionary where the keys are values and the values are keys. I think that's what it means. I'm just going to assume that's what it means. Okay, cool. So let's take in our dictionary here. Or we'll actually have to make another one because, and the values of the dictionary. Okay, cool. Let's do some tests. Say D equals a dictionary, and we'll say, what should our keys be? Just do something simple like last time. A, B, C, D, and this will be good. Okay, so we'll print, what was this called? Reverse dict with D, and we just expect that flip-flopped. I'm not going to write down what we expect because it's kind of obvious. And then let's do def reverse dict. We'll take in D. Yeah, that's fine. And then we'll say output dictionary is just going to, out D is going to be a empty dictionary, and then we'll say for K, V, and D dot items. We'll say out D sub V equals K, and return out D. Cool. Nice, that looks like it works. Let's do this. Pop that in there real quick. Good, that worked. All right, this is a great comprehension style question. So let's do a dictionary comprehension out of this real quick. This is going to be super easy. So we'll do V colon K for KV and D dot items. And then we'll return out D. Let's just return the dictionary directly like that. Okay, there we go. Anything? Anything? Oh, okay, that did run. Good. All right. Cool. There's two solutions for that. Looks like their suggested solution was exactly like my initial solution, so that's kind of cool. Right on. So removing dictionary keys and values. I think I'm just going to go straight for the challenges on this one, and yeah, we'll see. What is the proper way to make the dictionary initial dictionary? What? I think there's a typo there. Make the initial dictionary look like the result dictionary. Cats and dogs. So we need to delete other. I mean, I would use del. That's what I would do. Yeah, okay. So del is it's gonna remove, or it's gonna clean up, remove whatever you put after it. Del's kind of funny. Can't say I've used it that often in real life. But it's good to know about. It's definitely good to know about. So del, like I said, it's kind of funny. It's a keyword. It's not a function, but it's a keyword like def or if or something like that. And you can see in my syntax highlighting scheme, it highlights as this pinkish purple, like all the other keywords do. If we look at in or for, in, if, pass, whatever, while. So it's a keyword. It's built into Python, del, and it's going to just remove whatever you tell it to. So if I can actually remove this whole variable d, and if I print d now, it's going to give me a name error, just like d. It's the same thing as if d just never existed, right? Oops. It's the same error as if it didn't exist at all, right? So del will just delete it. And of course, we can just delete a specific element from D as well. Same thing will work with lists and indices. If you want to delete a specific element at a specific index in a list, you can do the same sort of thing. We got a question here. Del initial sub key. You could use pop, but del is more explicit. Yeah. Yeah, pop just has the side effect of like returning the value. I think you could totally use pop there, but yeah, I guess that's a good way to put it. Is del is more explicit, so we could do .pop as well. Same deal. Cool. Was there another one? Yeah. Obviously, like stuff like this, del initial sub 2. Since dictionaries aren't ordered, we can't number their pairs because they're not ordered. All right, cool. Yeah, you can store the popped val if you want, which can be really useful. Write a function called try to remove that has 3 arguments. Oh, I love it when they're numbered like this. Let's delete that. Okay. Okay. test key a key that might or might not be in the dictionary. Pop a parameter named pop whose default argument is true. The function should check to see if test key is in the dictionary. Okay, let me write some of this down here. Let's get a few of these things out from inside my head and offload them into the terminal here. So let's just do another dictionary, little mini dictionary here. And that's the first argument. Okay. So that'll be D. The second argument is a key that may or may not be in the dictionary. And the third argument is pop, which has a default of true. Cool. So let's do A, and let's do A, B, C, D. We'll look for E. E is not in the dictionary. And then we'll do these same ones again. We'll pass false for that third argument. I'm not passing it for the first one because I want it to assume it's default, which I'll get to in a second here. So this will be, I'll just do this. Okay. So this is going to be called test. Test dict, test key, and pop. Pop equals true. Okay, this is a little bit odd. Some of you may know this, some of you may not. This is how you set a default argument. So this is basically just saying if I don't pass a value for pop, just set it equal to true. And if I do pass a value to pop, it'll override the true with whatever I pass to it, i.e. what I'm doing down here. Since its default value is true, I assume the other thing that I can pass to it is false. Cool. Since pop holds a Boolean value, I'm just going to do if pop, because that's probably what I'm going to use it for, and we'll just pass for now and come back to that when the time is right. Okay. The function should check to see if test key is in dict. Let's just do that. Let's do that line of code right now. If test key in test dict, okay, is in test dict. Okay, we'll pass. If it is and pop is true, the function should pop the value of the input dictionary and return it. Okay, so let's do this in a little bit of a different order. I'll pop these, well, I'll put these in the initial condition where we're checking if it's in the dictionary. So we say if it's in there, then we may want to pop. Cool, okay. The function should pop the value of the input dictionary and return it. Oh. If test key is in test dict and pop is false, the function should simply remove the key value pair from the dictionary. What does it return? I guess nothing. Does it just not return anything? If test key is not in the dictionary, the function should return key not found. Okay. So, let's do this. If test key not in dictionary, then we'll return key not found. Otherwise, we'll check if pop is true. Elif pop. return d.pop. Test key. Test key. Else we'll just do that pop test key, and I think we just don't do anything. I think that's the thing. Okay. That's a ridiculous function. Or I just misunderstood it, which is not just possible, but downright likely. Oh, looks like it did. D is not defined. Did I? Of course I did. Of course I did. I don't... If I write a function that takes in a dictionary, like I just always call that input dictionary D, or almost always call it D, so that's just a habit of mine. I'll do that. Try that out. Yay. Hooray. I write a function called, okay, let's see. Not found. Oh, interesting. So I just noticed my tests weren't giving me what I thought it should. So if you look at this is actually a good opportunity to talk about this, because I've talked about mutability several times before, and perhaps some of you may see what's going on here. This is worth discussing anyways. I didn't write down what I expected this to return every time, but let's just do that real quick. So let's just say I want this to return 9. I want this one to return key not found. This one I want to return none. And this one I want to return key not found, I believe. So, if you look, this third test is failing. And at first I was like, wait, what? Why is that? You know, I submitted it and it passed. So why is it failing? It's actually doing what the problem statement asked us to do. And this is valid code in the sense that Python will execute it. But it does something. It commits a what do I call this? A crime of convention, I guess. This is not best practice to write a function that does this kind of thing. So let's just look at this. This takes in a dictionary, and it calls pop on that dictionary, on the dictionary that was passed into it. Let's just do this real quick. So under this circumstance, we take in D, we pop A, and we return that value. So if I print D, what do you expect? And I'll give you a second for this. Think about this. What do you expect D to print out as? Right? So let's just run it. Let's run it and see. B, C, and D. So there's no A, right? So this this variable went into this function and the function altered that variable, right? Pop is a mutable method for dictionaries and other things. So it changed D. It altered it, right? And we don't want to do that. Yeah. So this kind of thing can lead to sort of unpredictable results, and you'll see that, you know, that's what happened to me here. I'm like, wait, why was that test not passing when I thought it should? I thought I should be getting a different answer there, and I should have been according to what I was trying to do. But this is actually mutating its inputs, and you generally, I say generally, but I mean you should just always avoid this. Just absolutely always avoid it. Even though this question and learn is asking you to do it, it should be avoided at all costs. So this is what I'm going to do instead. I'm going to say D equals test dict dot copy, and I'm going to change that back to D there, and then we'll run it again. And then you can see we actually get all the right answers in this case. So in this case, I copied the dictionary internally inside the function, and I mutated that internal copy and then, you know, returned the pop or whatever. This is not going to pass in learn though. Oh, come on. Accidentally refreshed the page, because of course I did. Okay. This is not going to pass in learn. Learn is expecting that function to be, oh my gosh. Well, it does pass. Well, that's interesting. Oh, okay. Yeah, I guess it's gonna have the same behavior if you give it a new dictionary every time. But I kind of figured it would be testing the original dictionary, since it's saying to call pop on the dictionary. I assumed that they wanted it to be mutable, a mutable function, but yeah, that's good. So I think if it is going to accept this answer, I think I want to go back and kind of edit this to include the use of copy to make that clear. So cool. All right, let's do the next one. Okay, so write a function called delete dups. Cool. This function should take a dictionary as an argument. This function should go through the values inside the dictionary and remove any key value pair where the value occurs more than once inside the dictionary. Okay, cool. So we'll do D here. I'll copy our dictionary. Save this. Equals that. And we'll pass in this dict in here. Okay. And same sort of thing. So if I have D and 5, okay, but the question is, does it should it delete C, or should it delete D, or should it delete both? Okay, so this function should remove the second occurrence and third and fourth. Okay, so of the values, not the first occurrence. You should make a copy of the past dictionary. Okay, well that's interesting. It's saying remove the first occurrence, but which one is the first occurrence? It's a dictionary. There's no order to have like a first. There's just, I don't know. Maybe there's a little bit of suspension of disbelief that I have to practice here. Okay. This function should go through the values inside the dictionary and remove the key value pairs where the value occurs more than once inside the dictionary. Where the value occurs more than, okay. Not getting much out of that. The function should remove the second occurrence and third, fourth value. Not the first occurrence. Not that it matters. You should make a copy of the original past dictionary. The dictionary method copy makes a copy of the dictionary. Applied to this lesson occurs. Okay, that's just a link that's not present in the docstring. Okay, cool. So I'm just going to pretend like dictionaries have an order or obey an order. So cool. So what I want to do is return out D, and we'll just call this in D, and I'll say out D equals a dictionary, and we'll say scene vowels. Oh, actually, no, we don't need to do that. We can just say for KV in D. If V not in out D dot values. So if the value is not in the output dictionary, the values of the output dictionary, we will D sub K equals V, return out D. Good. Let's try that out, see what I get. Not enough values to unpack. Expected 2 got 1. Oh, because I didn't do dot items. Silly me. D is not defined. I did the same thing again. Gosh. Okay, so A, B, C, and I think what I want to do is, yeah, we'll just see. We'll see if at any point I get something that doesn't have C in it. So I think I could. Let's do this. For in range 100. We'll just call this 100 times. And we'll say if C not in this dot keys. Technically we don't need dot keys there, but then we'll do this. D, then we'll print D. Okay, and we'll just see if we get any prints to D after calling it 100 times. Okay, looks like not. That's kind of crazy. Okay, just call it 1,000 times. Well, okay, it appears to be obeying an order after now having called it several, what, like now a couple thousand times. Wow, okay. I think that should be broken, but Python disagrees with me, so you know what? You win, Python. You are the language, I am but a humble programmer. Okay, cool. So they're doing this thing with a currents list. I would have called this scene list. Initially, I was going to do something like this. For pairs in past d dot items, if pairs sub 1 not in occur list, then we append it. Else, we delete the return d. What? Oh, this is a subtractive solution. Oh, right, because this whole lesson is about using delete and remove and pop and stuff, right? I tend to every time I see like a subtractive solution where you start with something and you try to pare it down and like reduce its size to be what you want, I always think, I wonder if I can just approach that the opposite way, to start with something empty and then just accumulate the things, just add the things into the empty thing that I need. Because this is just a super vanilla accumulator pattern. This is really just simple, easy to deal with, whereas this is kind of, I don't know, what's the word, like overblown a little bit. It's not a pattern that you see like all the time like you do with just this. I mean, even just looking at this, it's that sort of, it looks like an accumulator pattern, you know, with the sort of swoop into the for loop and then the drop down to the return. Like there's so many accumulator pattern problems that just, you know, all kind of look the same, which might sound, oh, you might think, oh, that's boring, you know, you don't want to write vanilla boring code, but you actually do. You actually really do want to write vanilla boring code. It's exciting to write boring code. The reason is you can read boring code just really easily. If you kind of approach things that way, you know, and focus on good formatting and good naming and like consistent sort of vanilla solutions where possible, or where, you know, reasonable. Maybe there's like a good reason to do something other than this simple additive solution. But if there's not a good reason to do it, then this is just so easy and approachable. It's easy to read, it's easy to write, and easy to deal with, and that's an exciting thing. Once you've seen some of the code bases out there, yeah, I've seen some weirdly written code that you're just like, oh my gosh, just like pick a way of doing something, you know. But it is what it is. Okay. Cool. Copying a dictionary. Let's just jump right into this one. All right. So what do you think you shouldn't use the dictionary.copy equals D syntax? Oh, because we just told you to do so. Yes. Oh no, that's not really an answer. Um, because everything that you need, everything you read online about programming is right because it is about a technical subject. Yes, that's also correct. Okay, no, that's obviously not correct. Um, because doing so would only copy the keys to the dictionary. Because doing so results in two different variables referencing the same object. Yes, this is what happens. Recall that an object is a section of memory that holds the value, and therefore changing that object using one of the variables would change the object associated with the other variables since they are the same object. This is the case. I would explain it more, but this was the explanation. So, okay. What will be printed from the two print statements? Well, I could think about it, or I could run it, and you could too. True, false. Looks like it's going to be that one. Cool. All right. So let's just look at this. Let's dissect it. We have Dict 1 is a dictionary, Dict 2 is a copy, and then we make an assignment to 5 in both dictionaries, and we check. So we've modified them, we've modified both of the dictionaries, and then we check if the values are equal, and then we check if the IDs are equal. And you can see the values are equal, so we get true, and the IDs are not equal, so we get false. The ID will tell you if it's the same object or not. Checking the two IDs against each other will tell you if it's the same object or not. So we should expect true and false, and that's what we get. Copy. Yay, we get to write some code. So in the code block below, do the following steps. Use only the assignment operator to assign the contents of the personal dictionary, person1 dictionary, to a variable called person2. All right. Add a key called job status to person 2. Okay, so we'll say person 2 sub job status equals true. Copy method to make a copy of person 1 dictionary. We'll call it person 3. Delete job status from person 3. Cool. Okay. Well, that was easy. Nice little checklist. Good. Oops, sorry, it's getting so dark in here. It's actually not as dark as it looks on camera. I know it looks like I'm in like a almost completely dark room, but it's like just a regular amount of light. I just have really soft lighting in here. Cool. Dictionary accumulators. All right, let's just dip our toes into this one. And we'll be coming back to this one again later for sure. So, I always like to think of dictionary accumulators as having two forms. There's when you start with an empty dictionary, and let's say we do let's do a word frequency thing. So for word in, we'll do some text.split. Hey, there, hey. Okay. Okay, so we're going to get hey in there twice. So I could do if word not in d.keys, we'll say d sub word equals 1, else d sub word plus equals 1. Because, so, yeah, okay. We'll just do this. Okay. So hey occurs twice, there occurs once. Good. So this is what I would call like a full accumulator. This will add in keys that don't exist and modify keys that do exist, right? So this is the more like I see this as in line with the sort of main patterns of all the other accumulator patterns for all the other types, right? There's another pattern that dictionaries have that's slightly different, and maybe we could call this the categorical pattern. So let's say we have, I'll just delete all this because we're going to have different logic anyways. We have different categories, like let's say greater than 0.5, and we'll start that at 0, and then less than 0.5. Okay, and then we could do, I'm just going to import, and we'll just make a call to random.random. So we'll say for I in range, let's just do 50. For I in range 50. We'll say if random dot random is greater than or equal to 0.5, then we will d sub, I'm actually going to do this. We'll just say greater than or equal, and we'll just do less than 0.5. There we go. Alright, no, that's fine. D sub greater than or equal 0.5. Gotta make that a string. This equals, we'll say plus equals 1. And then otherwise, or else, we'll increment the other one. Okay, so just for context, random.random just returns a random number between 0 and 1. So a random float value between 0 and 1. Then we'll print D, and we'll just see how many events we got that were greater than or equal, and how many events that we got that were less than. Oops, put a space there. Cinch that up, make that one operator. Cool. Okay, so we got 21 that were greater than and 29 that were less than. So this is the categorical dictionary where we have predefined categories, and then this is not, I don't even think of this as dictionary accumulation. Not really, like, I mean, it is, because we're accumulating onto something that is in a dictionary, but we're not really accumulating onto the dictionary itself. We're accumulating to the values in the keys of the dictionary, right? So this is an integer accumulation pattern problem. This is an accumulation pattern with an integer that we just happens to be that the integers are in the dictionary. You know, it's like this is the same as if I said greater than, we'll just call it greater than and less. So this is the same sort of thing, right? This is not, you know, there's nothing weird about this. It's just an integer accumulator with two integers. And this is a dictionary accumulator with two keys, you know. This is kind of nice because you end up with those two things sort of categorized under one dictionary, which can be really useful. But it's not significantly different than this. It's just that the values that you're actually accumulating on, your actual accumulator targets, are the keys in the dictionary rather than the dictionary itself. Cool. So that's the thing to remember. Either you're accumulating keys and values, or you're accumulating on values, or excuse me, on keys. This first solution actually does both, and it's really common to just do both like this. So, I think this is a good place to wrap it up for now. I'm going to be leading Premium Prep today, so for those of you who are in Premium Prep, I will see you then. Sorry about not being able to get to that combinations question. It was yeah, just a little. I'm just like slow enough and dyslexic enough with stats stuff that was just didn't feel like quite a good use of time for a study hall stream for now, but yeah, perhaps in the future. Anyways, hope everybody enjoyed and hope to see you all back. DM me if you have any feedback. Let me know how the fidelity of the stream is. You're welcome. I'm glad to hear you learned. Yeah, you learned a lot. That's great to hear. Thank you. Yeah, definitely. Please feel free to share any feedback, good or bad. I definitely want to improve these and make these study hall sessions as awesome as they can be. So yeah. Without further ado, I suppose I will see you on this Wednesday for next study hall. Cool. All right. Bye-bye.